What's going on, guys? In this video we are going to see an example of transient analysis, and in this particular problem we have asked to find out the VC of t. Now let's look at the given question. This question is asking the switch has been closed for a long time. At t is equal to 0 the switch is opened. What is the voltage across the capacitor? That is our VC of t. Now to find the VC of t, what we have to do is we have to use this equation. VC of t is equal to VC of infinity plus VC of 0 minus VC of infinity times e power negative t over tau. Now we need to know VC of infinity, VC of 0, and also we have to find out the time constant tau. Let's write this one down. VC of infinity and VC of 0, and also we had to find out tau. Now we always start with the initial condition, VC of 0. To find this one out, what we do is we think about the initial condition. We know that when time is equal to negative infinity to 0, this is closed. At t is equal to 0, it's open. Now before that, it's closed. It's closed for a long time. So when it's closed for a long time, what's going to happen for this capacitor is it's going to be fully charged, and we treat this one as open. When it's fully charged, there's no more current flow through this one. So this is going to be treated as open. So this part we treat this one as that's actually does not exist at the initial condition, right? So we think like that and find the voltage across this one. So to find that one, what we have to do is if we figure out like what is the voltage across this part right here, that's going to be equivalent to the voltage across this capacitor. Now to find this one, we have to find the equivalent resistance, and since they are in parallel, we can use this equation. R equivalent is going to be multiplication of these two, 12 times 12 divided by the addition, that's going to be 12 plus 12. So this is going to be 144 divided by 24, that's going to be equivalent to 6 ohm. So 6 ohm is the equivalent resistance. Now to find the voltage across this one, we have to use the voltage division equation. That's going to be, let's say this is AB. So voltage across AB is going to be 6 times, not 6 times, 6 going to be up, and 12 times, 12 is our voltage, divided by the addition of, like here we have 12 ohm, 12 plus 6, because equivalent resistance, that's going to be in series with this one, right? So 12 plus 6, that's going to be 18. So here we are going to have 18. Now let's try to simplify this one. 18, 3, so this is going to be 2, this 2, so the voltage is going to be 4 voltage. So VC at time is equal to 0 is equal to 4 voltage. That is this one. So we have found out one of this part. This is 4 voltage and this part is done. Now we have to find out the time constant. To find out the time constant, we have to think about the open condition, because after time is equal to 0, this switch is going to be opened. So after this is opened, this part does not exist. So let's draw the new circuit we are going to have. We are going to have a new circuit like this, and we are going to have the capacitance. Okay, we are going to have the capacitance right here, and also we are going to have the equivalent resistance, that is 6 ohm, 6 ohm, and that's it. So we have the capacitance, that's 1 over 6 farad, and we have 6 ohm resistance. And if you remember, to find the time constant, we can use this equation. Tau is equal to R times C. Here this is R equivalent times C. C is the capacitance, R equivalent is the equivalent resistance. Now 6 times 1 over 6, that's going to give us 1 second, right? So 1 second is going to be just 1 second. Now we have the tau. Now let's see what's a VC infinity. VC infinity is like after this open, what's going to happen to the voltage, and after it's open, we are only going to have this one, right? These two parts right here. So what's going to happen is this charge is going to deplete after a certain time. So this circuit is going to be reach the steady state, and the voltage is going to decrease and it's going to reach 0 after a certain time, right? Because the battery is going to be like this capacitor is going to be fully lose all of the charges, right? So this is going to be 0 voltage when Vc is equal to infinity. So this is 0. Now we have all the values. We can plug it in this equation and find out our final answer. Now let's go ahead and write our final answer. Vc of t is going to be equivalent to, this one is going to be 0, so we can just leave it. And this one, Vc of 0 is 4, and 4 minus 0, that doesn't do anything, so we can just leave it. Then e power negative t over tau. Tau in our case, that's 1, right? So this is going to be just e power negative t volts, and this is going to be our final answer. I hope this helps. Thanks for watching.